So, scientist in you. So, we are building scientists. So, in this scientist in series, I am going to talk about the digital electronics area, under that analog to digital conversion, how it's happening. Here is my Microsoft profile. So, what I mean analog signals? It's nothing but it doesn't have any discrete values and it got a continuous values. The continuous signal with the time varying features. You are able to see based on the time a continuous changes in values is happening for another parameter. So which the time varying feature of the signal is a representation of some other time varying quantity. That's your analog signals. Whereas for the digital signals, it got two discrete values, either 0 or 1, off or on. So for computers to store it and to perform the processing, we need the digital data. So here comes your analog and digital converter. Where it's exactly used. You are able to see I got my audio signals which is an analog value, and this analog value is converted into digital value using analog to digital converter ADC, and afterwards these digital values will be stored in the memory and the data will be retrieved as a digital value into analog using a digital to analog converter, and you are able to see the audio here. This is how your analog to digital converter will work. You are able to see your analog values, and I got my values plotted. This is referred to as sampling. Let's move on to see what's sampling. So the typical example of analog to digital converter is your microphones. It takes your voice, convert them into an electrical signal, and it is stored as digital data. Here comes the steps involved in analog to digital conversion. The first one is like I got my analog value which is sampled, getting the discrete point values, distinct point values, and afterwards a quantization, an approximation value of which is mapped to get the data, and afterwards these data are encoded into digital data. That's how the two main steps are involved, that's sampling and holding, followed by quantization and encoding. So if you talk about sampling and holding, you are able to see this is my analog values, and I'm trying to map it to sample it, and afterwards we are trying to map or getting the exact discrete values. So measuring the analog values at uniform time intervals, and it reflects the sampled and hold signals. A digital approximation is done. This is how your sampling is done. And if you talk about the sampling types, the first one is ideal, natural and flat top. If you talk about ideal, based on a specific time interval, we'll be getting the values. And if you talk about the natural, you are able to see a pulse shot. If there is a varying amplitude in some area, map it and get the amplitude value. That's your natural sampling. And apart from that, flat top sampling is nothing but a sample and hold both are involved, but with a single amplitude values. I didn't match this one, but I matched this one. I matched this one, I didn't match this one. I matched this one, I didn't match this one. This is how your flat top will be. This is how your sampling types are. And I'm going to talk about quantization in my upcoming videos. Wait for a while. And these are my international awards and international certifications. And it's my software domain expertise areas, electronics domain expertise area, and this is my mechanical, aero and civil domain expertise areas. So we wish to send a lot of videos to you, technical videos, and this is my WhatsApp numbers. You can store it, and you can send a WhatsApp message with all your details so that we will send you the technical videos frequently. And it's my profile details and my personal request, please share this to your friends. Thank you.